This is about the trigonometric identities for proof from the booklet. So I think it's page 140. And so I'm just going to go through some of these examples out of the booklet. So example 191, we've got to show that 3 sine squared x plus 7 sine x is equal to cos squared minus 4 can be written in this form. So it can be written as 4 sine squared x plus 7 sine x plus 3 equals 0, which is effectively, that's a quadratic as well, which we could then go on to solve. But at the moment, all we're doing is we're just showing that we can write this in this format. So what we're going to use for this is the identity that we're given, which is that sine squared x plus cos squared x equals 1. And if we rearrange that, what we can do is we can get it in terms of cos, or we can get cos squared x in terms of sine squared x. So we can rewrite that as being cos squared x equals 1 minus sine squared x. And that's very useful because what we can then do is replace the cos squared x here by the 1 minus sine squared x. And the reason we want to do that is we want to get it all in terms of sine squared x, as we were required to do here. And so if we do that, we'll get 3 sine squared x plus 7 sine x, which we already had. And then that's going to be equal to 1 minus sine squared x. So replacing the cos squared x by the 1 minus sine squared x. And then take away 4. And now we're just going to get everything over to the left-hand side of the equals. So we're going to add sine squared x. So if we do that to both sides, we'll get 4 sine squared x. If we then also subtract 1, I'll just write this as well, the plus 7 sine x. We're going to add, subtract 1 from both sides, we'll get minus 1. Add 4 to both sides, plus 4. And that's now going to equal 0. And if we just tidy that up, we'll get 4 sine squared x plus 7 sine x plus 3 equals 0, as required. So we'll look at example 192 now. So here we're given that 5 sine 2x equals 2 cos 2x. And we've got to find the value of tan 2x. So this doesn't mean actually trying to find the value of x. We're just trying to rewrite this such that we've got tan 2x as the subject of this equation. And what we're going to use is the second identity that we've been given, which is that tan x is equal to sine x over cos x. And this will work whether or not it's sine x, whatever we replace the x by, it will still work. So in our case, it's actually not an x we've got, it's a 2x, but that's okay because we can say, well, tan 2x is equal to sine 2x over cos 2x. So what I'm going to do is I'm going to take our equation here, I'm going to divide both sides by cos 2x, which means we'll end up with 5 sine 2x over cos 2x, and that's now going to be equal to 2. I can then divide through by the 5, get that on the other side. I've got sine 2x over cos 2x, and that equals 2/5. And then from that, we can just use our identity and we can replace the tan 2x by, or replace the sine 2x over cos 2x by tan 2x. And we can say, well, tan 2x is equal to 2/5. So we've completed that one. We're now going to look at example 193 out of the book. So we've got to prove this identity. I'm just going to talk a little bit about the three equals things. So it's similar in a way to saying equals, but what it means is it's true for all values, and it's an identity, all values of x if we had an equation in it. So the difference between that and equals is if we had an equation where we said x is equal to 2 plus 5, that's only true for one value of x. So that's only true for the value of x, which is x equals 7. It's not true for any other values of x other than that. Whereas if we look at the identity symbol here, if we add x and then the 3 lines, or rather if we say 2x is equal to x plus x, then that is true for all values of x. Whatever value I substitute in for the x's, this still holds true. So in other words, just to summarize, this is only true for specific values of x, whereas this goes a step further and says that this would be true for all values of x. So that's an identity. So if we try and now prove this one, the first thing that we probably want to do is look at this tan theta. And also the method for doing these is we look at just one side of it and we try and get it to be the same as the other side. So in other words, what I'm going to do is I'm just going to look at this right hand side of this identity. So I'm going to look at the right hand side, and to the right hand side is sine theta, tan theta. And what I'm going to do is I'm going to manipulate it so that it looks exactly the same as the left hand side. So I'm not going to do anything like crossing over the identity symbol in the middle by adding cos theta, for example. I'm not going to do anything like that. I'm just going to work on the right hand side independently until it looks like the left hand side. So I'm going to first of all use our identity that we've just talked about, which is tan theta is sine theta over cos theta. So that means I'm going to get sine theta as we had before, and then replace the tan theta by sine theta over cos theta. If we multiply the top line there, that will give us sine squared theta over cos theta. We can now use again our identity, which is sine squared theta plus cos squared theta equals 1. And as before, we're just going to rearrange this. Now notice that the left hand side is just in terms of cos. So actually we want to try and replace the sine squared and make it a function of cos. So to do that, I can make the sine squared theta the subject of this equation. And so I'll get sine squared theta equals 1 minus cos squared theta. And I'm now going to replace the sine squared theta here by 1 minus cos squared theta. So what I'll get is 1 minus cos squared theta over cos theta. And I'm just going to split the fraction at the top there. So what I'll get is 1 over cos theta and then it's going to be minus cos squared theta over cos theta, and we're almost there. So we're going to get, we'll just simply divide the cos theta on the bottom with the square on the top. What I'll end up with is 1 over cos theta minus cos theta, which is equal to the left hand side as required. So we've proved it. We've managed to turn the right hand side into left hand side. So the next thing to do is now to work on these questions, which is more practice on this, and the book should be available for you to access online.